Hey guys. Alright, so a brief description of the multiplication counting rule. This is just a variance of the multiplication rule that we've already learned, and it still applies to what we've already learned, except it's being refined for specific things. So for this one, the multiplication counting rule, what it's used is to find the total number of possibilities. That's your denominator in your basic probability formula uh, for some sequence of events. So for a sequence of events in which the first event can occur in sub 1 ways, n we always use for sample space, or that denominator in your basic probability equation, total possible outcomes. So the total possible outcomes for one event and another event and another, and it can go on and on and on. And then how we just identify the differences between those sample spaces or total number of possibilities is they still use the letter n, but they use the subscript 1, 2, and 3, and so forth. So let's look at an actual example. Uh, a briefcase lock. So the thumb wheels on a briefcase lock, there's three of them, and they number between 0 and 9. So 10 possibilities. And then there's three of them, so I would have N1, N2, and N3. And through here you can see first thumb wheel we label as N sub 1, and from 0 to 9, so a total of 10. And the same applies to the second thumb wheel and the third thumb wheel. Okay, they all have a total of 10. And I've just labeled one N sub 1, N sub 2, and then N sub 3. And the basic formula for what I use, N sub 1 times N sub 2 times N sub 3, is simply 10 times 10 times 10, or 10 to the third, which equals 1,000. So 1,000 different possibilities to make a combination for just this basic thumb wheel. Alright, so let's work a problem using the multiplication counting rule. Alright, here's our problem. So the latest phone has come out and it has an 8-digit numeric code for security. So you have to enter in an 8-digit code in order to access the phone. Each of those digits range from 0 to 9. And digit values can be repeated. So we know this. We know each digit ranges from 0 to 9, and they can be repeated in the code. There's no limitations. What is the probability of someone guessing the correct code on the first try? Well, oftentimes with these problems, and at least find it for myself, is to make it visual. So if I were to turn around and think about this, I'm looking at getting a passcode that pops up on my phone, and these boxes that I'm drawing represent where the number will go. And I know in there that all of these are between 0 and 9, correct? So it gives me a total of how many digits to be able to enter in? 10. So each one of these is 10. And simply following the multiplication counting rules formula, what I'm looking at is to find my total possible outcomes, and that is n, which is simply our basic probability formula, the denominator, total possible outcomes. And what this turns into is our basic problem of, and we could say that's n sub 1, n sub 2, n sub 3, n sub 4, n sub 5, n sub 8. And I could say n sub 1 times n sub 2 times, and all the stuff in the middle, n sub 7 times n sub 8, which generalizes into saying 10 times 10 times all the way through until we get to the last 10, which in this case would simply be 10 to the 8th power. And 10 to the 8th power is simply a 1 with 8 zeros. 100 million. 100 million different possibilities. To say it as the probability, since it's on the first try, well, this is my favorable outcomes for that up here, right? So I've already found the probability, and I'll just leave it A instead of writing that in there. I've already found my denominator. That's 100 million. And on the first try, well, that would just mean there's only one try to be able to do it. So, and that's for the first try. So 1 out of 100 million chances to correctly guess the code. And of course, what our phones do is they put limitations on how many times the code can be entered, and you get to say that within your settings. Each time that a code was entered, and I had to say that this was probability of the first try. Okay, is what this equaled. Well, if I turned around and looked at it and I said, okay, what about after 3 tries? Well, this would be the first one, right? My next one would just be one less in that denominator because I have already used a try, right? That would actually be my second try. And in my third try, there would be even one less from that, right? And it would slowly go down. And as I multiply, I would end up multiplying those together to find out, well, if it were 3 tries, okay? But this will be your basic question that you're asked. And please, just think about it. Break it down, draw your little diagram, understand that what n means. They're not just throwing a new n at you, okay? Understand favorable incomes or and then total possible outcomes, how we've looked at that formula before, and be able to piece it together. Okay, guys, watch your publisher's videos. I know these problems can be tricky and difficult, but please persevere, structure, and critically think about your work. And good luck.